Well, hello everyone. Welcome to the Center for Transportation and the Environment's webinar, University Transit Projects Scaling Zero Emissions on Campus. My name is Thomas Duke, and I'm the university's market lead for CTE, and I'll be the moderator for today's webinar. I've worked on a number of university electrification projects, and I'm excited to see increased interest in university fleet transitions. Today, we're going to be hearing about university fleet transition projects, both in progress and completed, shared by CTE member companies supporting our efforts. Before we dive in, just some quick housekeeping notes. This webinar is being recorded, and the recording will be shared with all registered attendees after the event. Here's what you can expect from today's session. We're going to start with a brief introduction about CTE, and then we'll hear from our panelists, followed by a moderated Q&A session where we'll answer questions from the audience. If you have questions at any time, please submit them using the Q&A box. You don't have to wait until the end, and we can read the questions and pick the really good ones to talk about. Let's go ahead and get started. The CTE, the Center for Transportation and the Environment, we're a 501c3 nonprofit planning and engineering firm dedicated to advancing zero-emission transportation technologies, particularly in the medium and heavy-duty vehicle space. We began our work in the transit sector and have since expanded into a range of markets, including school and university fleets, municipal operations, ports, airports, and commercial trucking and logistics. We're managing more than 170 active projects right now, ranging from R&D and pilot demonstrations to vehicle deployments and full fleet transition planning. And we also assist with grant proposal development, and we advocate in DC on behalf of the zero emission industry. A little bit about me. I previously worked with the University of Georgia for 7 years, initially as their project manager on their initial deployment of 33 electric buses, which at the time was the largest deployment of a university-owned electric fleet. I met a lot of the people I work with now at CTE on that project, as well as people from Proterra and UGA's own Office of University Architects, which helped plan that project. I've then worked 6 more years at Georgia in a variety of roles supporting advanced transportation projects and technology. And since then, I've worked at CTE where I've seen increased interest from universities transitioning to a zero emission fleet, whether it's their bus, shuttles, or otherwise, like their support fleets, white fleets, etc. I learned a lot about deploying clean transportation at universities while at EGA, and at CTE, I want to share knowledge with others in the industry facing similar opportunities and challenges. Today, we're excited to be joined by a fantastic panel of experts in the zero emission space. We've got Adam Wilkham, the sales director for North America at EO Charging. We've got Nate Smith-Ide, senior sales manager at Forefront Power. Sam Hill-Crystal, Director of Business Development and Strategy at the Mobility House. Stephen Kofta, the Regional Sales Manager at BAE Systems. And Michael Lewis, the Director of UT Austin's Center for Electromechanics. We're going to begin with Adam Wilkham with EO Charging about their new project at the University of Georgia.
Thanks for that wonderful introduction, Thomas. Happy to be here with CTE and all of you wonderful people attending the webinar. As Thomas alluded to, my name is Adam Wilkham. I'm the sales director for North America for EO Charging. I've worked in the transportation industry for about 24 years, primarily with fixed route transit and the school bus markets. Been dedicated to electrification transitions for about the last 7 years now. So this nice segue with Thomas and his background with the University of Georgia, the topic that we're going to go over here. This is a really cool project that we just recently completed with UGA here at EO, taking a difficult situation and turning it around and making things a little more operational efficient there on site. You know, anytime you deal with technology change, adopting new technology, there's going to be a learning curve and there's going to be challenges that happen with the market. And this is an interesting and an innovative approach to getting things back in order after things didn't exactly go as planned. Next slide. I'll spend just 30 seconds on who we are at EO. So we're a 10-year-old company headquartered in London in the UK. We operate a tremendous amount of chargers around the world. We manage almost 120 gigawatt hours of energy with our load management software. And primarily our main two markets that we serve are transit busing and commercial fleet. Next slide, please. So let's talk about what happened over the last several years here at UGA. So a leader in electrification out of the gate, like Thomas alluded to, one of the largest electric bus deployments in the country at the time when they took delivery of those 33 buses. Delivered amazing results, 70% net greenhouse gas emission and 80% reduction in operating cost. But then disaster struck, something, anybody who's familiar with the transit bus industry knows the story of Proterra. Unfortunately, became insolvent in 2023, and their various parts of their company, the battery division, the bus division, the charging division, got sold off to different companies. What this meant, unfortunately, for the University of Georgia was now these chargers were essentially stranded assets. The support for these chargers was unclear. They became increasingly unreliable and left them in a really difficult situation where they were relying on things like mobile charging and just had to take buses out of service for large amounts of time. So they were looking for a solution to really remedy this thing without having to do a total redesign of their entire charging strategy there at the depot. That's when they engaged EO. And if you could go to the next slide, Thomas. Thank you. So what we did is we designed a solution for UGA to essentially use 80% of the equipment that was there underground to take out the existing Proterra chargers and install brand new chargers compliant with their V2G setup that they had there. And we needed this to happen really fast. That was the main goal there, to get this done as quickly as possible, to get the buses back on route, getting their students and staff served there on campus. So we were able to use all the existing switchgear, conduit, wire, concrete pads. Because this was such an urgent situation from a timing perspective, they actually used a purchasing consortium, NAPSPO, to do the procurement for this. And we were able to deliver this project in 10 days after contract signage for under $1 million total investment by UGA. So really happy ending. Everything there now is new. It's been replaced. It's operating. And essentially what we also did is we future-proofed this site for them a bit with our charge assurance products, where we essentially operate the software on the charger. We have a 24/7 tech center. We get notified automatically if there's a problem with the chargers there on site, so we can dispatch our technicians if needed. So again, really happy ending here with a difficult situation. Unfortunately, in electrification, this is probably going to continue to happen. But the nice thing is the market is maturing. There's companies, a lot of companies that are on this call that have really innovative solutions to come in and fix these types of situations. So it's not a total disaster at the end of the day. You can even take this one step further, right? There's a lot of fleet operators out there right now that, due to the technology changes and the uncertainty in the market, specifically with charging, they're handing operations over completely to companies like EO and some others on this call I know are in the same business, where they'll just, EO would own all this equipment and be responsible for its operation long term. Charging as a service is what this is called, but it's definitely growing in popularity. So if you haven't looked into that, check it out. It's certainly a pretty interesting way to do operations here when it comes to charging buses. So, but I'll wrap it up there. Hope you all have some great questions at the end, and I'll be happy to take those. With that, I'll pass it over to Nate.
Thanks, Adam. And thank you, CTE team, for the opportunity to be here today, and all of you who have chosen to attend this. Happy Thursday. My name is Nate Smith-Hyde, and I represent a firm called Forefront Power. Next slide, please. I'll get into the sort of commercial about Forefront Power in a second, but what I would love to cover with you all today is a brief overview of how to get higher ed campuses from sort of the ideation or conceptualization phase of these fleet electrification projects through construction, completion, and ongoing asset management. So really trying to take a holistic perspective on this fleet electrification journey, which is complex and riddled with pitfalls, some of which Adam alluded to. So really trying to help us all sort of wrap our arms around these pretty complex projects. Next slide, please. So Forefront Power is a nationwide renewable turnkey renewable developer. So we focus specifically on solar storage and EV charging projects. What I'll get into in a second is sort of, when you think intuitively about these fleet electrification projects, your mind probably goes towards, okay, well, how do I offset this maybe additional electrical load associated with these EV charging stations with on-site renewables? That's something that Forefront Power specializes in. So pairing solar and storage with your EV charging infrastructure. Next slide, please. Next slide, please. Thank you. You'll hear me say that a lot. So in terms of how Forefront, how we can partner with higher ed campuses, there are sort of two different solutions here. What we're speaking about today is primarily the fleet side of our solution base, and then there's also another aspect to our offering which focuses specifically on public-facing EV charging projects. So with both of these, really again trying to work with campuses to get from the sort of strategic plan to the development, permitting, survey, construction, and then ongoing operations and maintenance. Next slide, please. I mentioned solar and storage and on-site renewables in tandem with fleet electrification. There are three main ways in which on-site renewables do pair well with your EV charging infrastructure. The first being what I had mentioned initially, which would be, how do we offset increased energy costs associated with your EV charging infrastructure, particularly during periods of high demand charges? So solar is a great coincidental use case for EV charging infrastructure. So when the sun is shining and cars are parked underneath what you can see on the left-hand side of this page via solar canopy, that solar project is producing energy. That energy is flowing directly into the charging stations themselves. So really trying to offset or avoid all of the associated increased energy charges with your EV charging infrastructure. Storage is a great on-site storage is a great application as well, particularly during your shoulder time of day. So before the sun is shining, and then after at night. So the storage essentially the storage application essentially elongating the value of your solar project. And then again, really with the mindset of trying to offset additional energy charges and demand charges from that EV charging infrastructure. Another aspect of pairing on-site renewables with EV charging would be microgrid functionality. So if there is a demand, I know that Michael Lewis from UT might be talking about this a little bit, but if there's any demand for microgrid functionality on your campus, or if there's specific fleet vehicles that you'd like to operate uninterrupted, then having islandable resources on your site, energy resources like solar and storage, allow your EV charging stations to retain their functionality even throughout grid outages. And then finally, this one's sort of less industry specific and more so what you'd imagine on any construction project really is, if you're going to rip up your parking lot and put in a bunch of EV charging stations, it might be a time to consider solar and storage. because as you see again from the image on the left, a lot of the construction, can happen, typically happens in the same, footprint in your parking lot. So it's a great opportunity to take advantage of construction, timelines and efficiencies. And also if you're going to work with your utility to potentially upgrade electrical infrastructure to install the projects, then, it could be a good time to also consider upgrading that infrastructure to accommodate on-site renewables. Next slide, please. So getting from, again, ideation, conceptualization, one of the biggest roadblocks that we see in actually executing these EV charging projects is paying for them. And one amazing way that these projects can become more accessible for higher ed campuses is by pursuing incentives. Incentives come in a variety of forms. What we typically see are via rebates and reimbursements. And they'll come from, yes, the federal government still does have programs that fund EV charging deployment. States absolutely do. Most utilities do as well. What we see specifically in the state of California is actually air district funding is a huge pot of money and is actually really contributing more than you might assume to these EV charging projects. So really keeping in mind all of your funding incentive resources. Next slide, please. Next slide, please. In terms of actually, going to your board and having these projects approved, Forefront Power is, and not to be too salesy, but Forefront Power and is aligned with many cooperative purchasing agencies. It's not just Forefront Power; many other firms also are aligned with these. The headline from this slide is really incentives come and go. Being nimble with your procurement, which you can be through cooperative purchasing agencies, is a great way of taking advantage of those incentives. Next slide, please. Next slide, please. So thank you for listening to me. I hope that was helpful and informative and valuable to you. Again, what Forefront Power tries to do and what we're really excited to work with CTE is really trying to get all of these projects in the ground and help at every step of the way. So with that, I'll hand it off to Sam Hill-Crystal from the Mobility House. The Mobility House is a partner of ours, and he'll be talking to you a little bit about their software solutions and applications.
Awesome. Thank you, Nate. Thanks for that presentation. Thanks to the CTE team for having me as well. And of course, thanks to everyone who's joined. It's good to see great attendance, some existing partners and customers, as well as a lot of new faces. So yeah, I'll jump into it here. I'm Sam Hill-Crystal. I'm Director of Strategy and Business Development at the Mobility House, North America. And I'm going to be really focused on the software side of this equation, what we call a charging management system. So you just heard from two turnkey providers who are, going to wrap up an entire solution from idea through, operations. And really, no matter what charging solution you get, especially for a fleet, you're going to have some software layer that helps with both fleet operations as well as on-site energy management, operational cost reduction, capital cost reduction. There's a lot of things to be had from choosing the right software system. So I want to give an overview of that. Quickly, background on Mobility House. We were actually founded in 2009, so we've been in this world for a long time. We started in Munich, Germany. We're now been in the US for about 7 years. We're a global company. We have offices around Europe, US, and Singapore as well. Next slide. A few more statistics here, but really just focused on this middle one up top. 2,500 sites managed under our Charge Pilot product. That's what I'm going to be talking about today. Next slide. Quick overview of projects. This is a little outdated map, but we have a good footprint across the country, multiple university sites under management. I'll talk about a case study in WashU St. Louis in a few slides. So just a quick background, this slide has, for which fleets does Charge Pilot provide the most value, but definitely think about this broadly as well. If you're not familiar with charging management systems, if your fleet or the vehicles on your campus have any one of these characteristics, there's going to be some value in looking at a charging management software. Of course, if there's multiple of these characteristics, you're going to be able to capture even more value. And really the core question here is, how can you minimize capital costs, so infrastructure that you have to build to support your charging stations? How can you minimize operational costs, so your electricity costs? I'll talk about how to do that in a cool way with solar as well. And then how do you do all of that without compromising fleet operations? And that's really the core question that CMSs are answering. There's certainly additional functionality around charger errors and things like that. But really, at the core of it, that's the optimization question that these softwares help you address. Next slide. A little bit of a complicated slide here, but I just want to give folks a picture of what our system looks like. So there's definitely a range of system architectures that you'll see in the software space. Everything from cloud only to hybrid architectures, and that's what we have. That's what we've employed. So we have a local device on site in most of our applications. A lot of intelligence lives there, and so if you're relying on software to monitor stations, collect data, save you money on your electricity bills, maybe even integrate with a backup generator, there's a lot of things that can be done. You don't want that functionality to rely on internet connectivity to your site, whether that's cellular or Wi-Fi. It's bound to have issues, and so we use a local device to ensure reliability and make sure we're not compromising any operations. Next slide. Zooming out, just to giving you a sense, right, of where does the software sit? It really touches a lot of different things. Everything on the upper left, I already saw a question about vehicle grid integration, right? So if there's any sort of interaction with the utility, demand response programs, maybe even vehicle to grid, we have a couple active sites in the US where we're actually exporting to the grid. That'll be plugged into the software. There's also integration potentially with operational systems that a fleet might already use, telematics, etc. Then there's going to be integration with on-site energy systems, and that's a really strong area for mobility houses. So one of the areas that we focus, and I'm going to talk about a case study now, which encapsulates a lot of this. Next slide. So WashU St. Louis, deployment of ours, relatively recently commissioned. It's been a great site. We were just out there last week, so took some pictures here. It's a mixed fleet, different service vehicles as well as shuttles. Next slide. So a summary, our software is deployed across 2 different sites. At this site, we are controlling, or at both sites, we're controlling power electronics stations. But one of the features of any good CMS, in my opinion, is that it uses open standards. So you don't want to be locked into a charger vendor. If you change your mind, company goes out of business, you want to be able to buy a new charger and have that still be integrated into your system. Flip side, if you don't like us, you want to work with someone else, you should be able to kick us off and work with someone new and not be sort of tied into any sort of vertically integrated system. So that's kind of our approach. And so I just wanted to flag that. A couple interesting things about this site. First is this was a direct CMS procurement. So they actually went out and said, okay, charging management is important enough for us that this is a category of product that we want to buy on our own. And we want to go through a process to do that. And so, you should get great software provided by turnkey providers. A lot of them have awesome solutions. They work with partners like us. But you could also consider, sort of taking the control of that. And so maybe an increasing pattern we see in universities. I think this really started in transit fleets, sort of procuring software on its own, separate from chargers and vehicles, and then kind of integrating that themselves. But it just depends on kind of the resources you have at your organization and how you want to go. But I wanted to flag that. Second thing is that these chargers are on the same service, particularly the one at the bigger site here. They're on the same electrical service as a building. And so we need to be aware of that. We need to be aware of all of the electricity use, and we need to make sure that we're not tripping any breakers. And so we have an integrated system where we can monitor building load, and that creates a lot of efficiencies on the CapEx side because you don't have to expand a service as big as you might need to. We can just turn up charging when the AC is off or the lights are down at night. And then finally, and relevant to what Nate was discussing, if you have solar on site, you're using that to control energy costs already, then often you may actually get more value consuming that solar with your own load rather than sending it back to the grid where you might not get paid by the utility for the full amount. And so we've actually have a solution where we can integrate charging directly into the solar. We can maximize how much charging happens from solar without any microgrid. It's just a direct integration facilitated by our system. So if you go to the next slide, just pulled a graphic from our dashboard. You can see on the bottom right, you can see the black line is load at the site. So you can actually see it's below zero, right? They're exporting. And the blue line is charging load. And so you can see this little blip where charging load kicked up, total load went closer, less negative to zero, but was still negative. And so that's an instance where 100% of the vehicle load was actually met by the solar in real time. So that was from last week. So I just wanted to show you all what it actually looks like. I think that's it for me, right on time. So yeah, I'll hand it over to Stephen from BAE, and we can pivot off charging and talk about vehicles.
Thanks, Sam. Appreciate it. That's some great stuff there that Sam, Nate, and Adam have been talking about. Hello, everyone. Hello, CTE. Thank you very much for having us on. I'm Stephen Kofta, the U.S. Regional Sales Manager for BAE. And today, we're going to shift gears a little bit and talk about what we call electrification simplified. Next slide, please. So just a little bit about BAE before we jump in. We are a national defense aerospace company. However, we've been in transit propulsion systems now for over 29 years. We'll be celebrating 30 next summer, so that's really exciting. We have over 19,000 electric drive propulsion systems operating worldwide. We're the only propulsion system that has won grants, and we've heard some people talk about grants prior to this. We're going 2 million EV miles each year with our hybrid electric systems, and some industry firsts. We were the first to do engine start stop, which we'll talk about a little later on, fully electric accessories. We also offer, besides hybrid propulsion, battery electric and hydrogen propulsion. And then, of course, geofence green zones, which we'll get to in a few moments. Next slide, please. Next slide, please. For the sake of time, I'm not going to read that statement. It's really talking about best way forward. We've heard a lot about infrastructure today, and infrastructure you need. And I believe you need it before the bus. And so the solution we're talking about here today is hybrid electric buses. So what are the concerns about everything that we're talking about today? It's about saving fuel, MPG. I'll get into that in a moment. Reducing emissions, definitely. Infrastructure costs and concerns. Technology risks, and of course, developing my workforce. We believe we can help you with this by going with a hybrid electric bus first while you're getting all that infrastructure completed. Next slide, please. So a little bit about workforce development, because when you're going from a diesel or a gas fleet even to a zero emission fleet, it's really difficult. And so you're going to have those challenges in your shop and things. And one of those hurdles would be batteries. These are hybrid batteries. And so, I mean, the same thing as a lithium ion battery in an electric bus, but not as complicated, if I could use that word. There's no midlife replacement with some of these batteries. They're lower initial cost. They're much easier to monitor and work on. When you go into an electric bus, it is more difficult. There is more to learn. And so this is what we call a bridge technology for that workforce development, which we feel is very, very important. Next slide, please. Miles per gallon. Let's talk about that for a moment. Yeah, we're all trying to get away from diesel. However, again, infrastructure, zero emission, it takes a long time. It's hard to do. These are numbers that just came out in May with our system, and they're highlighted in green. But we have now doubled what you can do in a diesel bus with a hybrid electric bus. And you can see, I just walked through the slide really quickly. Manhattan is an actual route in Manhattan. We're getting 5.3 miles per gallon. Orange County, California, 6.7. And then UDDS is an urban route that they have created themselves. And we were at over 7, almost 8 miles per gallon. Next slide, please. And so, of course, we're talking from universities here and transit agencies across the country, and these are just average numbers. We went back a whole entire year to take a look at different zones of the country: hot, cold, high altitude, low altitude, humidity, no humidity, and you can see what we're averaging across the country. And we could do the same for your university as you're getting, again, your infrastructure and things set to go zero emissions. Next slide, please. And so what we really want to sit down and just talk to you about today are what electrification simplified is, what green zones and geofencing is. Geofencing is when and where you want it without grid charging infrastructure. And so while you're working on that, you get in hybrid buses. We can do start-stop. I think we all have it in our cars. I think we're all familiar with that. We were the first to do that in heavy-duty transit. Then you have arrive and go, where when the bus is coming to the stop, we can shut that engine off. It can cruise in emission-free, and then it will leave emission-free. And then that diesel engine, again, will be used as a generator to charge the batteries. And then we have what's called the extended range or geofencing. Next slide. And this is a great slide. So what we can do are two things here. One, you can highlight a route within your university that you say it's a mile-long route. You can green zone that when the bus is on that, or we can designate a whole area, what's called geofencing. So when the bus enters that area, the engine shuts off. And that's really what's key here, is shutting the engine off, being on your campus and around, and your pickups, battery electric, no emissions. What we'd like to say is you can go as long as you want on it, but really that sweet spot is 3 miles. For every mile that you are running in a geofenced area, you need about 1.5 miles for that diesel engine to recharge those batteries. So that's extremely important. And so it's technology that we've had out there for years. Again, we have over 1,200 transit agencies who are using this, and be glad to answer any of your questions later on here. I believe my time is up, so I'm going to pass it on to Michael Lewis. He's going to talk about some exciting things with hydrogen fuel cell. Michael, it's all yours.
Thank you, Stephen. Thanks, everyone. So we're going to transition quite a bit. A lot of the conversation so far has been around electric vehicles and charging infrastructure. And I'm going to speak to you about some of our experience in deploying hydrogen fuel cell vehicles and hydrogen refueling infrastructure at the University of Texas at Austin. Next slide, please. So I am the director of an organized research unit at UT Austin known as the Center for Electromechanics. At CEM, we do applied research. We like to build and test things through academic, government, and industry partnerships with the goal of transitioning power and energy solutions into products and students into future leaders. Next slide. So a lot of this presentation is going to be focused on a new hydrogen R&D facility here at UT Austin known as the Hydrogen Proto Hub. It was put in with funding from the Department of Energy, and at the end of this year, we'll wrap up the scope under that DOE project. But this facility is a first of its kind hydrogen demonstration and proving ground, where we have multiple forms of hydrogen generation and multiple end uses all in one site. So a lot of what we're doing here may not apply to your future needs if you're deploying fuel cell buses or some other fuel cell vehicle fleet. But either way, I think there's a lot of good lessons to be learned. On the next slide, it does list our project partners and some timelines. I'm providing this to you all, assuming we'll provide these slides at the end of the presentation, just so you have an idea here. But really, it's just to say that there's a lot of interest in hydrogen. It's not a nascent industry, and there are a lot of people looking into this. So the next slide gives us an overview of the Proto Hub facility. There's a lot of equipment here. I will leave it to you later on to kind of go through these through this slide and read all the pieces of equipment. But we are making hydrogen on site with a steam methane reformer. So that makes hydrogen from natural gas. We're also making hydrogen from the electrolysis of water. We have a storage and distribution system of hydrogen on site. We have our supervisory control room with all the safety aspects integrated into it for the site, and we'll touch on that in more detail. There's also a fuel cell power plant on the site, providing clean hydrogen-based power to our computing center. So really replicating that microgrid type operation. But then we also have a couple of vehicle fueling dispensers at 350 bar and 700 bar on site. So moving on to the next slide, the next several slides, we're going to go through different timelines and show a bunch of pictures. I'm not going to read all this. But you can see if you look across the top here, this project's about 5 years in the making. There was a good year or so up front of just designing and laying things out. We started this project in 2020, which did not help things at all, right in the middle of the pandemic. But then once we had everything kind of planned out, we were a good couple of years between construction, commissioning, testing, and getting the site up and running. And a lot of that, actually, we had experienced a lot of delays just in our safety reviews from our UT Fire Marshal team and our environmental health and safety team. So one of our lessons learned, and we'll repeat this later, is get those authorities having jurisdiction over your site involved early and often. On the next slide, I just illustrate here with a lot of photos, different parts of the construction and installation process. So it's prepping the groundwork, getting utilities into place, bringing equipment on the site, and then just starting to interconnect everything together electrically or by the gas or plumbing that's needed for it. On the next slide, as I said, the AHJs are very important if you are considering hydrogen and fuel cell vehicles on your campus. Getting them involved early and often is needed. There are a lot of steps along the way. You need to do process hazard analysis. You need to think about what happens if you have a fire, what happens if you have a hydrogen leak, so gas dispersion analysis, and then make sure various safety systems are implemented, especially notification of the fire department, and then just how hydrogen equipment, where it's located with respect to the personnel and infrastructure. So on the next slide, once again, a lot of photos here just documenting all the work that went into safety on this site, the different analyses. Are we covering the site with our flame detectors? What do hydrogen leaks look like around the site? What do fires look like around the site as well? So moving on, we then, this slide talks about our implementation timeline for the hydrogen compression, fueling, and dispensing portion of this. And really, the highlight here is that throughout the first year demonstration of the first year and a half, we've had a number of components that have failed in this system, but it's all associated with the balance of plant, not the fundamental technologies within the boxes. And one thing that's helped us out a lot was having redundancy. So having 2 dispensers versus 1, we go from roughly about a 60% uptime on each unit to a total 90% uptime of at least being able to fuel vehicles at some point. The next slide just shows a lot more of those pictures of things along the way, just to kind of show you that these are real. The one to highlight here when it comes to hydrogen vehicle and fueling is the one with the red box. So we did do fueling protocol testing with Toyota before we were kind of approved by or allowed by them to refuel their Toyota Mirais with our dispensers. And this is something that any hydrogen fueling station will need to do, make sure those fueling and dispenser systems are to code. And then the last slide is just really our fuel cell vehicle portion of this project. So with this project, we've been operating 3 Toyota Mirai fuel cell vehicles. They effectively have performed flawlessly. They've done a number of things. We've done big road trips with them and so forth. But it's all here really to say that we've talked a lot in this call about electric buses or electric charging infrastructure. And a hydrogen vehicle is another zero emission alternative for you that provides greater range than what you might see with electric vehicles, gets past a lot of the charging issues, right? The time to charge as well as staging chargers and trying to reduce your grid loads. Now you do have to put in fueling stations and so forth, but there are advantages, especially when you think about scale with fuel cell vehicles. The next slide just highlights some more photos, shows our big range test. We've hosted other vehicles at this site too. We had our very first public fueling of a Hyundai Nexo as well on site, but we've done a lot of cool things with them, even doing our own service of these vehicles since there are no fuel cell vehicle dealers in Texas that can service these vehicles. And then kind of my last main slide here is really just what did we learn in implementing this system? What do you need to think about as you're moving forward? Obviously, hydrogen technology can be a challenge even for commercial systems. What we found is the fundamental technologies, as I said earlier, are pretty sound, but that system integration and the balance of plant around those technologies is challenging. So the fuel cells, the electrolyzers, a lot of those fundamental technologies haven't been an issue for us, but it's been valves and regulators and power supplies that have failed on us. And that's really just speaking to the growing pains of this industry. The vendors are figuring out what pieces, what components work well in their systems and which do not. So redundancy will be key as you're deploying a hydrogen system. And then just bringing in your authority having jurisdiction early and often. For us, since we're a university state-owned property, we didn't have to go to the city of Austin, their regulatory officials. We worked internal to UT, but still they're learning just as we're learning along the way, or actually we're teaching them more so along the way. But then their interpretation of codes, our vendors' interpretations of codes, ours, they always vary. There's a lot of interpretation that can be done within a National Fire Protection Agency code. So really just engaging them early and often is the biggest lesson learned here. They'll make your deployment a success. And with that, the last slide is just saying thank you and some contact information if you need it.
Thanks, guys. I appreciate Adam, Sam, Stephen, Mike. Awesome. Awesome. Let's get into questions. I've got a few. The first one, I'm going to direct it at Adam, just for relevance. For the EO University of Georgia implementation, it was mentioned that this is a vehicle-to-grid solution. Could you expand on the grid integration? How much power is returned to the grid? And how do these vehicles support with things like peak shaving?
Yeah, I wish I could go into the details on that. I don't have a ton of the detailed information, but I would definitely be happy to follow up with whoever asked that question and provide them some site specifics on the metrics as to the V2G operation there. It is operational and it has been for some time, so I can definitely get some more detail to you on that.
Okay, thank you. I believe we have the name of who put it in, and we can find the email. We'll get it done.
Yeah,
All
for sure.
right. I have three more questions, and honestly, they're not related to any specific presentation, and they center around. Oh yeah, just another one just came in for UT. What advice do you have for a university interested in using fuel cell electric buses? How do we even start this process?
Yeah, sure. So I guess first you got to find that funding, right? I think other presenters talked about the incentives and funding. Working with somebody like CTE would definitely help in that regard. The first step is, figuring out that bus solution platform. I don't think there are many vendors that are offering fuel cell buses at this point. So who's going to be your bus? And then when it comes to your fueling and infrastructure side, I imagine CT could help out with this. There, if you want to go it your own and do it yourself, you can. But there are industrial gas suppliers, say like Air Liquide and Lindy's of the world, that are putting in fueling stations. There are other groups like First Element that are also doing fueling stations. So I would be reaching out to those types of groups to understand those infrastructure requirements. As well. So the bus, can you get a bus? But then, thinking about that fueling. The hardest part possibly might be, even if you can get the station and the bus, how you source your hydrogen is also going to be a challenge. So where's that nearby hydrogen facility or plant that can deliver hydrogen to your site if you are not going to produce it yourself on site, which is possible. But that can be quite daunting if your fleet is big, for sure.
Thanks, Michael. That relates quite closely to another question we received, and kind of two, both touching on funding and partnerships. I'm going to go with this one. This is for anyone. What are some efficiencies or advantages to using outside project partners for a transition versus developing a transition plan in-house in a university context? Anyone can take this one.
Well, as far as writing grants, I mean, CTE is the way I would go. And I've watched CTE work really the last 7 years in the zero emission space of partnering with transit agencies, partnering with universities. And they have such a huge reach that they can find out all of your hard questions. That's what CTE can do. And they've got expert grant writers, of course, and everything, but they have the experts there and they know where they are, and they reach out to us to ask the tough questions to make sure that you can get the correct funding and the correct project ongoing.
I think I can chime in a little bit here too. I don't, in our experience with the hydrogen system, we did do this internally, our research staff, but we've been working with hydrogen for 20 years, right? We we kind of know what we're doing. It was not our first fueling station that we put on our campus. We put our first fueling station on the campus back in 2006. So, and operated that for 15 years. But, the people within the university that have that authority over it, the fire marshal and EHS, we're not very educated in hydrogen, maybe at a high level, but all the ins and outs and the various codes, we were teaching them along the way. So, there's going to be value in bringing someone from outside potentially for your university there. I imagine you'll run into the same issue. I will also say that, our fire marshal actually wanted us to bring in a third party risk assessment firm while we were developing this site. So there's always going to be a need for that professional engineer who's going to sign off on the site, no matter where you're doing this. Even your university officials are going to want to see that. So these fueling station providers or developers, or if you're trying to do it in-house, working with a group, we worked with Baker Risk Consulting, but a group such as that knows hydrogen systems and has reviewed and done all the safety studies for hydrogen stations could help be that sort of independent professional engineering firm that really can sign off and make your university officials feel very comfortable with what you're doing.
Now, I can just touch on it quickly from the electrification side. If you're looking at electric vehicles, I mean, you probably, especially if it's the transportation department working on this, right? Like, you understand your vehicle operations and routes really well. You can, you understand your internal budgets, your internal stakeholders, and there's a lot of work to be done there. And so when it comes to translating that into, how much power do I need at a site like that, doing that math and kind of knowing how to find efficiencies there and make some recommendations to say, okay, here's the minimum you would need to get started here, like that's, I think, stuff that can be done well by external vendors. And that's, something that teammates or other companies could do, not even consultants, but we just have, analytics and simulation teams that can help with getting a sense of what it's going to take to get a project started, while the university staff handles all of the other pieces I mentioned.
Thank you. Thanks, Sam. Thanks, Michael. Thanks, Stephen. Thanks, Stephen, for the CTE plug as well. We'll move on to the next question. They're coming in now. Let's go with this one. I want to start, and we got 10 minutes left. I think we got time for 2, maybe 3 more. I want to start figuring out what vehicles I should electrify now versus later and understand what kind of chargers and other materials we need. How should I get started? And this one is for Nate. So you're on the spot, Nate.
I'm ready. Thank you for the question. How to get started, I think, as Sam alluded to, is relying on these resources, relying on someone like Forefront Power to sort of like try to simplify to the best of our ability the complexity of these projects at the point that you're currently at, right? So that would start with a meeting and understanding the basics of the project's goals and the current infrastructure. So we'd look at stuff like location of where you would like to install charging stations, what sorts of vehicles you're interested in, right? So like how to best charge those vehicles. And then from there, we at least have sort of a conceptual package of that project. And then, a third party like Forefront Power would be able to go out and understand, costs, and then with those costs, figure out incentives to align with those costs to offset those. So really trying to get, again, from like the first sort of like ideation phase of this, I would urge you to rely on these third parties, right? To do our jobs. This is what we do every day. To outsource, as much of that brain power as you can to these third parties. And it starts with a meeting, and then a conceptualization, and then we open Pandora's box, and we figure out exactly what makes sense for you. But everyone here on this call has the capabilities. These panelists have the capabilities of starting that journey with you. Absolutely. I was very broad. I hope that I gave something of value there.
You did. And there are tons of questions. They all came in at the end. That's okay. We're not going to be able to get to all of them, but the cool thing about CTE, nonprofit consulting firm, we can answer your questions for free. Just send them our way. You can email me at thomas@cte.tv, and we'll reply if you have questions we don't get to. One more. This is a big one. I bet a lot of people are thinking about this. Federal funding was a huge help to closing the funding gap in university transition projects. Yes. With the federal funding landscape less certain, where can I go to find funding for a fleet transition at my campus? / are there any funding opportunities currently open? Before I pass it to the panelist, CTE, we'll find it for you. If it exists, we're looking for it, and we can be your partner as a nonprofit in your journey to fleet transition. That's the broad answer. The easy one for me. Anyone else, feel free to chime in. I know things are changing, but it's not over. The technology is going to have to stand on its own, and honestly, we're just getting started. So, anyone?
Yeah, I guess I'll jump in and just echo, your last statement there, Thomas. All hope is not lost when it comes to funding. There's a lot of noise right now because things are fairly uncertain, but a lot of the federal dollars are still protected and still there, yet some of the requirements are probably changing. There's a lot of state level programs that can help with these types of projects. And don't forget about your local utility companies. They sometimes will have their own projects as well to help get this off the ground. So it sometimes can take a village, but Yeah, CTE, you have an expert here at your disposal to use, so they know about all of those programs and where they all lie, because it can be complex when you're just starting, for sure.
One more thing, if y'all are familiar with the NEVI program, the National Electric Vehicle Infrastructure Formula Program, it has been released for 2025, and states release their own RFPs at the state level later on this year. And your eligibility will depend on how your campus is set up, but we can walk you through that if you may be eligible for funding through NEVI. So reach out to CTE. We got 4 minutes. Time for one more. Any insights about market trends for zero emission paratransit fleet options? And Sam has grabbed this one.
Yeah, I just wanted to touch on this. A couple examples from the school bus space. So maybe not exactly the same, but I think it's valuable. A couple of projects we've been involved with, transporting students with various specialized education needs or transportation needs, lifts, etc. I think one trend we've seen, there's definitely some vehicle options coming on, like more smaller shuttle type vehicles. Often those were provided, or for a while those were all built on the same chassis, like from Ford, and it was just like there was a big crunch around the pandemic and some supply, but I think that's loosening up, which is good. And then I think a really key thing there is the operations are often much more complicated because you have much more varied routes. You might have redispatch, pickups, going to different places, or you might have long routes, and so there's a lot more need for, like, what I would talk about is the software ecosystem. So if you're electrifying those vehicles, you probably need it, like maybe a integration with a routing tool or a dispatch tool, or maybe you need closer coordination between the transportation side and the charging side. Whereas for
Sure.
like fixed route shuttles, maybe the shuttles don't change more often than every school year, and so it's relatively easy to handle. So I've seen a couple of trends there, and there was just a project announcement we had for Little Rock schools, and that's all focused on students with individualized education needs. So it has some of the same characteristics, and it's not exactly the same, but I thought that might be helpful.
It is, and thank you so much. That certainly works.
And on the fuel cell side, hydrogen, I don't think there are any paratransit offerings really out there. That's something we've actually been talking to CT about, trying to do a research project or a prototype demonstration project on, right? So
Not yet.
not yet. Mm-hmm.
Okay. Well, thank you, everyone. We're gonna stop questions now. A minute and a half left, so the rest should come via email, or just if you're interested in a vehicle or fleet transition, we want to help you. We want to put together a project team, maybe with our members, including our panelists today, to help you achieve your goals. And if you got questions or want to engage further, just shoot me an email. It's thomas@cte.tv. And for our members, our annual meeting will be this October 20th and 21st in Atlanta. We'll have more information, how to engage with us in other markets, including the university space, but also many others. Tons of great networking opportunities with other members from CTE, and maybe faces you've seen in the past. We'd love to see you again. It's going to be a great time, as always. And I'd like to thank everyone for coming, and I hope to talk to any of you guys soon. Bye.